Hi, grade 11 students. We're going to start this year in grade 11 by second part of trigonometry. We're going to talk first of all of compound angle identities. What do we mean by compound angle identities? Compound angle identities is the cosine of a sum of two angles. For example, you're going to split an angle into two sums. For example, if you have 100 degree, you can write it as 40 degree plus 60 degree. So these are the formulas for cosine A alpha plus beta, cosine alpha minus beta, sine, and the tangent. So here, these formulas we need to memorize. But however, by proof, we got these formulas. So for example, you have here a circle. I'm going to move fast in the proofs because no need to know how to prove it, but we cannot write anything without saying from where we got it. So that's why if I want to prove it here, we took a trigonometric circle whose radius is 1. I have a point B. Suppose the angle here is alpha, and here the angle is beta. From here till here, this is alpha and this is whole beta. So the components of the point B cosine alpha sine beta, and the point C cosine beta sine beta. Now I'm going to do the distance B to C. You know the formula, you difference square root difference of the abscissa square plus difference of the ordinate square. If you continue, if you expand, you're going to get this expression. But we know that cosine square alpha plus sine square alpha is 1, and cosine square beta plus sine square beta is 1. So at the end, we're going to get this property, this formula, this answer. If I rotate this triangle so that it starts by A, so we said this is alpha and this is all beta. So the angle between in this triangle will be beta minus alpha. I want to rotate it so that the two triangles are isometric, it's the same. So here, instead of having these coordinates, so I'm going to have the coordinates of that point, which is 1, 0. And since the angle here is beta minus alpha, I have these two. So if I do the distance formula here again, and I will get that result. If I, because the two distance AB square here and AB square here are the same, so it's going to lead me to this formula, which is cosine beta minus alpha is cosine beta cosine alpha plus sine beta sine alpha. As I said, I have moved very fast in the proof. You can read it by yourself if you are interested. But what concerns me is that you need to memorize these formulas of called compound angle identities, which are 6 formulas. How we're going to use it? We're going to take example. We're going to find cosine 15. You all know that 15 is not a remarkable angle. We cannot find it unless we use a graphical calculator. But now we can find it using compound angle identities. I'm going to ask myself, I want a sum or difference of two remarkable angles so that I will get 15. So the easiest one is 45 minus 30. 45 is a remarkable angle and 30 is a remarkable angle. So cosine 15 is cosine 45 minus 30. So it's cosine A minus B. And we know that cosine A minus B is cosine A cosine B plus sine A sine B. So cosine A minus B is cosine 45 cosine 30 plus sine 45 sine 30. You know that cosine 45 radical 2 over 2, cosine 30 radical 3 over 2, sine 45 radical 2 over 2 times half, you're going to get radical 6 plus radical 2 over 4. So now we can find the cosine of 15. I know many of you find difficulty when they have a pi. Pi over 12 is 180. If you want to translate it in degree, is 180 over 12. So it's also 15. So 15, you all know, it is also 45 minus 30. But since it's in radian, I can write it as 45 as pi over 4 and 30 as pi over 6. But I have this minus here first. We know from before that tangent minus alpha is minus tangent alpha. So this minus, you can carry it outside. And you put alpha inside. So that's what I did. I have put minus outside, and this is as we said, 15 degree, which is pi over 12. It's tangent A minus tangent B. Tangent A minus tangent B is tangent A minus tangent B over 1 plus tangent A tangent B. So if I apply the property here, I'm going to get tangent pi over 4 minus tangent pi over 6 over 1 plus tangent pi over 4, tangent pi over 6. We know that tangent pi over 4 is 1, tangent pi over 6, remarkable angle 1 over radical 3. And here, if you multiply 1 times 1 over radical 3, if you do same denominator, you're going to get radical 3 minus 1 over all radical 3, radical 3 plus 1 over all radical 3, radical 3 and radical 3 cancel out, so I have left this with this one, and the minus here outside, we wrote it here before the expression. I have 7 pi over 12. Concerning 7 pi over 12, we know that, as I said before, many find difficulties in pi. So pi over 12 is 15 degrees. So 7 times 15 is 105. So you can ask yourself, you can have infinitely many ways of finding 105 degrees. You can say for 105, for example, can be 150. I want sum of remarkable angles, I mean multiple of 30 or 45 minus 45. Somebody others can tell me it can be written, for example, 45 plus 60. You can use whatever you want, but I want a sum of remarkable angle. Here I have used this one in this example. Maybe this example is easier for you even. 150 degrees, you know, it is a multiple of 30. It's 530. So it's 5 pi over 6 minus pi over 4. And sine A minus B, if you see the formula up, it is sine A cosine B minus cosine A sine B. So if you're going to apply it, sine 5 pi over 6 cosine pi over 4 minus cosine 5 pi over 6 sine pi over 4. Sine 5 pi over 6 is 1 over 2 cosine pi over 4 radical 2 over 2. Here the same story. We're going to get radical 2 minus radical 6 over 4. Now I want secant 75. If you want to find the secant, we need to find first of all cosine 75 and then we convert it. 75, it's not a remarkable angle, but I can say because it ends with 5, let me start by 45. It's 45 plus 30. Plus 30. So let me do cosine 45 plus 30. So cosine A plus B is cosine A cosine B minus sine A sine B. Cosine 45 radical 2 over 2 times cosine 30 radical 3 over 2 minus this expression. I'm going to get radical 6 minus radical 2 over 4. But at the end, what I want is cosine. Let me erase to write the answer here. I want secant, because I want the secant, so I must write it as inverse of what I got. So the answer will be finally 4 over radical 6 minus radical 2. So I hope that you enjoyed that video and you got the lesson. I see you tomorrow in school.